Hey there, and welcome. Let's kick off with a question that might just change how you think about your own mind. What if consciousness isn't just something that happens in the brain, but something that emerges from the very fields that ripple through the universe? In this journey together, we're diving into an idea that's as bold as it is fascinating. What if consciousness is a computational process? One not limited to neurons and biology, but carried by electromagnetic fields, quantum interactions, or even universal patterns of information. We'll walk through how computation evolved, from vacuum tubes to quantum computers, and explore the possibility that our minds are doing something surprisingly similar. Whether you're a tech lover, a philosopher, or just curious, you're in for something special. Let's start with the basics. How do we actually move and process information in the physical world? One of the most powerful answers: electromagnetic fields. These fields are everywhere, in circuits, wireless devices, even in your brain. In classical electronics, EM fields carry digital data. In quantum systems, they guide qubits. In your brain? Maybe they're doing even more. Think about it: every digital message, every neural signal, every quantum operation, it all rides on the same invisible waves. So while information isn't just limited to EM signals, they play a starring role in everything from cell phones to consciousness. If we think of information as changes in physical states, EM fields are often the vehicle for those changes, especially in systems that think. That's why understanding electromagnetic information could be a major step toward understanding ourselves. Time to rewind. Imagine it's the late 1800s. Edison discovers that electrons flow through a vacuum. That tiny insight becomes the foundation of controlled electrical circuits. Then comes Fleming's diode, and de Forest's triode, which adds amplification to the mix. Suddenly, we can control and boost signals. Machines begin to process logic on their own. Sure, these tubes were huge and fragile, but they kicked off something big: the age of machine logic. The first spark of electronic intelligence. This is where machines began to evolve from simple tools to reactive, semi-autonomous systems, and they did it all through electromagnetic control. With vacuum tubes giving us control over signals, we took the next step: building logic into circuits. Think of it like teaching machines to speak in binary. And, or, not, these simple gates became the building blocks of digital thought. You can see a couple on this slide. Every time you unlock your phone or run an app, logic gates are behind the scenes making it all work. What's remarkable is that these tiny decisions, yes/no, true/false, stack up into the complex behaviors of today's digital world. And what's making those gates flip and switch? You guessed it, electromagnetic fields. Then came the superstar of modern electronics, the transistor. Invented in 1948, this tiny component changed everything. It was smaller, faster, and way more reliable than vacuum tubes. Transistors allowed us to shrink circuits, lower power use, and boost performance, all while still using EM fields to do the heavy lifting. This era marks when computing went from labs to desktops. Transistors allowed us to build real, scalable systems, and suddenly the idea of a thinking machine wasn't science fiction anymore. The brain of your smartphone today? It's made of billions of transistors, all dancing to the tune of electromagnetic fields. Why use one transistor when you can use thousands? Or millions? That's the idea behind integrated circuits. Jack Kilby's vision of putting multiple components on a single chip led to Moore's law: double the transistors every 2 years. From supercomputers to the phone in your pocket, all of it became possible because of the scale. On the slide, we see examples of circuit integration, including latch designs and ICs. These innovations allowed us to go from basic logic to full computing platforms on a chip. And at the heart of it all? EM fields again, flowing through tiny paths to keep it all running. Now, let's go beyond digital. Not all computation uses zeros and ones. Some systems process information as waves. Think of terahertz communication or analog signal processing. Or even your brain, it might work more like a symphony of waveforms than a digital computer. Variables like frequency and phase might be how nature computes. Wave-based computing is smoother, richer, and maybe even more expressive. It lets us compute with patterns, not just symbols. And that opens a door to understanding how the brain might really function, not just with spikes, but with oscillations, rhythms, and resonance. Let there be light. Optical computing is about using photons, not electrons, to compute. This slide shows optic gates, where light carries information using color, direction, and intensity. It's super fast and incredibly efficient. Light can compute in parallel, at the speed of, well, light. And here's a twist: some scientists believe the brain might be using light, too. Tiny flashes of biophotons have been observed in neurons. Could light be part of our internal thought process? If so, we might need to rethink what mental illumination really means. Now we're entering the quantum zone. Quantum computers don't use regular bits, they use qubits, which can be 0, 1, or both at once. This means they can solve problems in new, powerful ways. What controls those qubits? Electromagnetic fields, microwave pulses, laser beams, magnetic traps. It's all field-based again. The visuals here give us a snapshot of how quantum computing has grown. What's fascinating is that in quantum field theory, particles themselves are viewed as excitations of underlying fields. So maybe consciousness, too, arises from patterns in fields, just like qubits do. This is where physics, computing, and philosophy start to merge. Okay, here's where things get really interesting. What if all of this, signals, waves, light, quantum fields, is building towards something deeper? Some researchers believe consciousness might be an emergent property of coherent electromagnetic computations. From McFadden's semi-theory to Penrose and Hameroff's orchestra to integrated information theory, the idea is the same, that awareness might be field-based. These theories suggest that the brain might not just be generating consciousness, but tuning into it, like an antenna picking up a deeper frequency. So maybe what we've seen in this whole computational journey, from vacuum tubes to quantum systems, isn't just the evolution of machines. Maybe it's the unveiling of how the universe thinks. Thanks for coming on this journey. Let's keep exploring, keep asking, and maybe one day, truly understand what's going on inside our minds.